Alright, let's look at section 2.3. Question 1, they give you the total cost, total revenue. Okay, these are quadratics or linear. And they ask you to find the break-even point. So you set cost equal to revenue. So this guy equals that guy. Subtract 130x, you get this guy. Factor it if you can, which I could. I get 40 or 50, both legitimate answers. Cost and revenue are given in question 3. Find the break-even points. So you set them equal to each other. Throw everything to one side. Factor if you can. Set each one equal to 0. You get 50 or 300. Both legitimate answers. Number 4. Same thing. They give you two equations. Set them equal to each other. Throw everything to one side, factor, or use quadratic formula, and you get 80 or 20. Number 6, profit is given by this function, and you're limited to less than 100 for x. So I wrote it in descending order, set it equal to 0, that's how you find the break-even point. Set it equal to 0, throw everything to one side and factor, and you get 10 or 110. Well, you got to throw out the 110 because your factory can't produce that many. Number 7, find the maximum revenue for the revenue function given. I write it in descending order. Now I know my A and my B and my C. I figure out the fraction here. That's my x coordinate of my vertex. And I plug that in, and I get my y coordinate. So my maximum revenue is this number here, the y coordinate of my vertex. Number 9, in a monopoly market, revenue is unchanged. It's always price times the number of items x, right? Selling price times x. But they give you the price in this form. It's a different price than, it's not just a number, it's an equation, a line. So you plug that in for P times X, multiply it out, write it in descending order. Now you know your A, your B, and your C. You plug them in here, simplify, and you get 175. You plug it back into the original formula, and you get 87.5. So number of units sold, what price will maximize revenue? That's the 87.5. is your price. This is the number of units that will maximize revenue. Okay. Number 11, profit from a certain commodity is given. Find a level of production that yields the maximum profit and find that maximum profit. They're talking about vertex here. So write this in descending order. You know what your A and your B and your C are. Plug them into negative B over 2A. And you get 55. Then go back and plug these into the original function, and you get 2025. So the number of units to produce a maximum profit is 55. The maximum profit is actually 2025. Now 17, it says suppose a company has fixed cost of 28,000 and a variable cost of 2/5 x plus 222. Remember, cost function is simply the fixed costs are added, and then over here it's the number of units times the cost per unit. Well, they say the cost per unit is 2/5 x plus 222. Cost per unit times x plus fixed cost. Revenue is the selling price times x. Well, they give you the selling price in the question as this right here, this item in the parentheses. Now distribute everything, write it in descending order. Okay, so now they want you to find the break-even point, so you set cost equal to revenue. I threw everything to one side, and luckily it factored. And I got 28 and 1,000. Then part B says maximum revenue. Find that by taking the revenue function and again finding negative B over 2A and throwing that into the revenue function, and you get this. That is your maximum revenue. And C says form the profit function and find the maximum profit. So revenue minus cost, and you get your profit right here. Now you know your A, B, and C. You plug it into, this is negative B over 2A. When you simplify, you get 514. Plug it back into the original function, and you get 236196. That's your maximum profit. Now what's part D? What price will maximize the profit? Well, remember the price was given way back here. Here's your price. Just this guy in the parentheses. 1250 minus 2/3, 3/5 x. Well, we know what number of x needs to do to maximize profit, so you use 514 there, and you get 491.6. Okay, and then 18. Okay, 18. Suppose a company has a fixed cost of 300 and a variable cost of 3/4 x plus 1460. So your fixed cost is 300, your variable cost is this times the number of units. Revenue is x, number of units, times the selling price, and they tell you the selling price is 1500 minus 1/4 x. So now you multiply this by x and that by x and write it out, and then you multiply each of these by x and you write it out. And now they want to find the break-even point. So when does cost equal revenue? These guys set equal to each other. Throw everything to one side, factor if you can, and you get 10 and 30. Find the maximum revenue. Well, you take the revenue function and do negative b over 2a again. And it's 3,000 for x, and you plug that into the original revenue, and you get 2.25 million for your maximum revenue. Part C says form the profit function and find maximum profit. So remember, profit is simply just revenue minus cost. Here's your revenue, here's your cost, subtract them. Put them in parentheses, that's important. Okay, so when you drop the parentheses, the first part doesn't change, but the second part, each one gets hit by a negative. When you combine like terms, you get this guy. And so negative b over 2a is negative 40 over 2 times negative 1, which is 20. Okay, and then here they ask you what the price is. And so now, go back to the original problem, you know what your price is 1500 minus 1/4 x. Okay, and so you plug in x equals 20 into this guy and you get 1490. Alright, and then 23 says supply and demand function are given. Okay, it says sketch them both in the first quadrant and label the market equilibrium point. So I did that here. Okay, so I made each tick mark 1, and I think I made each tick mark 2 here. Not sure. Part C says algebraically determine the market equilibrium point. So if they're both set equal to P, you can set them equal to each other. I get rid of my fractions by multiplying everything by 4. I bring everything to one side, and then factor, but you're probably not going to be able to factor that. I would use quadratic formula right here. 13, 24, and minus 304 is your A, your B, and your C. So you end up with 4 or negative 5.85. You throw out the negative. With the positive, you get 14 when you plug it back into either equation. And so 414 is your quantity and price. 25. Alright, they ask you to find the market equilibrium quantity and equilibrium price. So these are supply and demand. They're both set equal to P, so you can set them equal to each other. You throw everything to one side. I divided by 2 to make these numbers smaller. Makes it easier to factor. Each one set to 0 gives you negative 10.5 or positive 10. I throw out the negative. Plug this back into either equation and you get 196. So 10 is the quantity, equilibrium quantity, and 186 is the equilibrium price. And they do the same thing here with D. D is harder, or 27 is harder because you got all these P squareds in there. So I solved each one for Q. So I take the first one, demand, and I bring the p squared to the right, then I divide by 4, and I get q equals this guy. And then for supply, I got this here, and I move the p and the 300 to the other side. Then I divide it by 2, and I get this guy. So now I got q equals this and q equals that. I can set them equal to each other. I get rid of fractions by multiplying by 4. Throw everything to one side. Again, this one is actually, you can use the square root method because there is no middle term. Notice there's a x squared or p squared. There's a constant, but there's no x term or p term, which means you can bring the constant to the left and divide by 3. And now you've got something squared equals a number, so you square root both sides and you get plus or minus 2708. And you got to throw out the negative, so you keep only the 2708 positive. Plug that into either equation and you get q is 217. Okay, I plugged it into this guy here. So my quantity is 217 and my price is 2708. 28, you've got supply and demand here, and they want you to find the market equilibrium point. So you take each one separately, and I'm going to solve each one for q. So I bring the 4 to the right, makes it minus. I divide by a -1, and I get this guy. And this one, I divide both sides by p plus 2, and I immediately get what q is. So now I say this minus 42 plus 4p equals this fraction here. And then to get rid of the fractions, I multiply both sides by p plus 2. Those cancel here, leave you just 2100. This one here, a lot to multiply out, you get a lot of terms. Bring the 21 over and combine like terms, you get this guy. I factored out a 2 first, then I factored it to this, but again, you can do quadratic formula with this guy. I would recommend that. Factoring is too hard. So when you set it equal to 0 and solve, you get negative 19.5 or positive 28. So negative 19 is out. And so then for quantity, I used this one, minus 42 plus 4p, where we now know p is 28. So quantity is 70, and the price is $28. 31, they give you supply and demand, okay? And this one, you take the first one, write it here, and solve it for q by bringing the 2p and the 10 over, and then dividing by a -1. Here I divided by p plus 10, and then I subtracted 30. So now I got this guy equals that, and to get rid of the fractions, I multiply by that common denominator. Over here, this cancels with that, but this guy also hits that. So you got all 4 terms here. You got this guy times this gives you these two, and you still have your numerator of 7200. Okay, so when you throw everything to one side, you get this guy. I divided by 2 to make my numbers smaller. I was able to factor, set each one equal to 0, and I got negative 70 and positive 50. So I threw out the negative. Throwing the positive 50 into here, I get 2 times 50 minus 10 is 90. And the same thing here with this one. I solved it for p. I took this one and brought the q to the right and divided by 2. And on this one I solved it for p by dividing by q. So now I got these two guys equal to each other, and I solved by multiplying both by 2q. So 2q times 1/2 q gives you just q squared. 2q times 25 is 50q. And this one, your q's cancel, but you still have a 2 that hits the top. Throw everything to one side and factor. You got your 2 equations. They set out to give you a minus 20 and a positive 10. You throw out the minus 20. And then they plugged it back into this guy to find their p. So p is $30 and quantity is 10.